Hi everyone, I'm David Wismer recording this video from Arequipa, Peru. And I just finished up a project that I'm pretty excited about. And that project has to do with fighting styles, specifically clustering UFC fighters by their different fighting styles. So I make bets with my friends on all of the UFC fights, and you can get points by guessing the correct winner of a fight, and then you can get bonus points for guessing the correct round of the fight and the correct method of victory, meaning submission, TKO, or a decision victory. And if you guess a winner by decision, you can get 3 points. If you actually guess the correct round and finishing method, for instance, a knockout in the first round, you can actually get a bonus point and get 4 points for that particular fight. So, with all of that in mind, I've always been interested in building some sort of project that could gather all of the information I would need together for a fight and give me an edge over my friends when making these bets. So the goal of this particular project was to use historical UFC data to generate clusters of fighters by their fighting style, and then organize that data in a way that informs my betting and the betting of other people that use this tool on the outcome of a fight, so the winner, the winning round, the winning method. And then I wanted to deploy that information in a web app that I could regularly update without too much trouble, so that I could have this information for every fight card going forward. Just for those unfamiliar, the UFC is the Ultimate Fighting Championship, and fights last either 5 rounds or 3 rounds, depending on if it's a championship or non-championship fight, or also main events are 5 rounds. And fights are won by either knockout, where an opponent cannot continue, a submission, where the opponent cannot continue due to some sort of choke or hold on a limb, for instance, or by judge's decision, which is when it goes the full 3 or 5 rounds that are scheduled, and then the judges decide the winner of the fight. Quickly on my data sources, I got everything from UFCstats.com through a web scraper. I used Scrapey to do my web scraping, really nice object-oriented web scraper that interacts nicely with Postgres, which is what I use for my data storage. I use SQL Alchemy to get my data out of Postgres and into Postgres. I use pandas and NumPy to do data cleaning, feature engineering, that sort of thing. Clustering was done with scikit-learn, and then ultimately all of the visualization was done with Tableau, and I also organized everything onto a Streamlit application. On the web scraping, everything starts at a list of events and fights. From each event, you go to the specific fight within that event, and then once you're in the fight, you can go to all of the details within that fight within each round. So for instance, here you're looking at Fight Night Font versus Garbrandt. When you dig into that, you can see the list of fights in screenshot 2. And then if you dig into one of those particular fights, for instance, Norma Dumont versus Felicia Spencer, in screenshot 3 over here, you'll see who won and lost the fight, how long it was, how many rounds were scheduled, details about the scoring, and then down below, details about all of the significant strikes and a lot of the grappling and control metrics as well. So my model included fight data from UFCstats.com, and I scraped everything from 1998 through 2021. And then when I actually did my clustering, I needed to filter for fighters that had enough data to be worth coming up with their particular style. So the clustering algorithm that I built uses fighters who had at least 10 fights and at least 15 rounds of data available from UFCstats.com. This ultimately left me with approximately 400 fights and 400 fighters and 6,200 individual fights to be used in the construction of my fighting style clusters. For feature engineering, I was trying to capture the style of a fighter. So it's important to look at what do they do in striking, grappling, what are the aspects of control, how often are they controlled, how often do they control their opponent. I also needed to look at the offensive and defensive side of things, both the intentions and the capabilities of these fighters. So for instance, strikes attempted, how many strikes are they attempting? Are they a volume striker? Do they prefer to strike less? What are their capabilities? Do their strikes tend to knock people to the ground? Do their strikes land often? What's their rate of taking down their opponent? things like that. And I have a couple different categories of statistics. The first is time-based rates. So these are things like takedowns per minute, significant strikes landed per minute. And the denominator is different for certain metrics, and I'll talk about that here in a bit. I also calculated several fight metric ratios. For instance, takedown success rate, which would be successful takedowns divided by attempted takedowns of their opponent. And then the final one is finish rates. So this would be number of TKO wins per fight, for instance, number of submission wins per fight. This is going to be percentages. But I actually excluded these in my cluster construction. And the reason for that is it puts too much emphasis on how successful the fighter is and not enough emphasis on what their intentions are during the fight. And I wanted this to be about fighting style, not about success in the octagon. So back to those time-based features. We've got three different types of times. There's control time, there's controlled time, and then there's neutral time. So control time is when the fighter is in a controlling position. Generally, this is when they are on top of the opponent while on the ground. When they're being controlled, it's the opposite, when the fighter is on the bottom. And then there's neutral time, which is generally when they're standing and neither fighter is in control. They're kind of both in neutral space. So different metrics, you want to use a different time denominator. For instance, let's look at takedowns landed and takedowns attempted. I want to divide these by the amount of neutral time in a fight rather than the total time in a fight, for instance. So, for instance, say a fighter, 30 seconds into the round, they take down their opponent and then they keep them on the ground for the rest of the round. Well, that's 5 minutes. So what I really am more interested in knowing is that they took them down in 30 seconds of neutral time rather than they took them down one time in a 5-minute span. It's really important to know what happened during the neutral time. Whereas with, for instance, control time, I'm interested to know how much did the opponent control, or did the fighter control their opponent in the total time available. And then the other is control plus neutral time. So this is taking out time when the opponent is, or when the fighter is being controlled, because I'm interested to know how many strikes are they landing and attempting when they have their choice. I don't really care so much about when the fighter is being controlled. Generally, when a fighter is being controlled, they're focused on getting up, getting out of a controlled position rather than landing strikes and this kind of thing. Next up is feature reduction. First, to reduce features, the obvious thing to do is just look at correlations. I looked at seaborne heat maps and correlation tables and removed clear and obvious collinearity. And then also, I'm trying to reduce variance inflation factor. So I ran VIF from stats models, a Python library, and then I'm trying to remove features and run subsequent runs of VIF in order to get everything below, say, a benchmark of 10. So here's what that might look like. In my first run of VIF, variance inflation factor, you'll see there's several things in here that are above 10. I also wanted to get rid of finish rates. You'll see those were in my first run up at the top: finish rate, opponent finish rate, TKO win per fight, etc. But you'll see in the middle there KD per minute and KD per significant strike. These are knockdowns per minute or per significant strike. They're very highly correlated, so I wanted to remove things like that and get my VIF outputs down. So in my final run, you can see here is the final list of features that I went with, and they're all well below the benchmark of 10. And here is that final feature list. So head strike rate, how often is the fighter aiming for the head versus the body or the legs? Distance strike rate, meaning how often is the fighter throwing strikes from distance rather than from a clinch or the ground position. Significant strikes attempted per minute, significant strike accuracy, takedowns landed per minute, control time per minute. Then we've got knockdowns per significant strike. So this means how many times did the fighter knock down their opponent versus how many times they landed strikes on their opponent. This is a measure of kind of their power and their ability to knock down the opponent. Then we've got the opponent knockdowns per significant strike. So the opposite, looking at a fighter's durability. Significant strikes absorbed per minute. So this is aspects of defense when striking, or also do they like to stay close or away. takedowns absorbed per minute, and then opponent takedowns per minute. And so to cluster fighters by the fighting style, I first needed to transform my data. And because I was going to use distance-based algorithms like k-means, I used standard scaler to scale my data beforehand. And then I also used principal component analysis in an attempt to reduce dimensionality. I didn't have so many dimensions in the first place, so this didn't do a whole lot, but it did reduce dimensionality a little bit, which will be nice because I do have plans to recreate these clusters on a regular basis and present them regularly. So any sort of performance improvement I can get is welcome. The clustering methodology that I ultimately went with was k-means. I did test out dbScan, hierarchical agglomerative clustering, Gaussian mixture, but k-means was ultimately the best because it came out with very similar results to HAC and Gaussian mixture, but it also allows for calculating similarity scores between fighters and then the cluster centroids. We'll see why that's important in a bit. For a case selection, I used the elbow selection method. I chose a K of 10. This was due to a combination of looking at the silhouette scores and the elbow method, but also just trial and error with clustering and picking a K that produced clusters that were clearly different and could be labeled differently due to their different characteristics. So when I was assigning labels to the different style clusters, what I did was looked at the distribution of fight metrics for the given fighting style I was trying to label versus the aggregate of all other styles to define the characteristics that make the cluster what it is. And so I'd like to go through an example, and the example is the stand and bang cluster. And what defines this cluster is their ability to keep the fight on the feet, and then also the way they strike. They have high volume, they also get hit a lot, and they win a lot by TKO. Some examples of this fighter style are Max Holloway, Angela Hill, and Calvin Kattar. So let's take a look at some of the details here. What you're looking at in the upper left corner is takedowns absorbed per minute, and you can see that stand and bang fighters generally have lower takedowns absorbed per minute. And then down in the bottom left, you see takedowns attempted per minute, and it's even more dramatic here that these fighters do not attempt takedowns. They obviously have decent grappling if they can keep it on the feet by not absorbing many takedowns, but they're also not trying to take their opponent down, which means they prefer to have the fight standing. Next, we're looking at some striking statistics, and in the upper left corner, you see significant strikes absorbed per minute, and you can see it's much higher than all other clusters generally. And then in the bottom left, you see significant strikes landed per minute, which is also on the higher end, meaning that these fighters land a lot, they get hit a lot, they're willing to stand and trade punches. And then finally, now we're looking at in the upper left corner, opponent knockdowns per significant strike. This has to do with the fighter's durability. Very low in terms of how often these fighters get knocked down. So it's a very durable fighter. And then in the bottom left, you're looking at TKO wins per fight, slightly above average versus the other clusters. So these really are fighters who want to keep the fight standing. They're hard to knock down. They can hang around and they can get the knockout, which is where the stand and bang style name comes from. So now I'd like to quickly go through some of the other fighting styles. The first one is the chinny grappler. So these are fighters that win with their grappling, but when they can't put their grappling into place, they frequently get knocked out. This includes fighters like Chael Sonnen, Curtis Blades, and Matt Hughes. Next up is the glass cannon. This is kind of a typical term in MMA, and this really has to do with getting the knockout or being knocked out yourself. So this is fighters like Alistair Overeem, Luke Rockhold. Next is the grinded out fighters. I'm actually going to move my window here so I can see who these examples are at the bottom. So these are your scrappy fighters. These are fighters that don't often get the finish, and when they lose, they typically take it to decision, so they're hard to finish as well. They get controlled, but they still land strikes at a high rate, meaning that they're able to put out output even though they lose out in the grappling oftentimes. These are fighters like Tim Elliott, Aljamain Sterling, and Neil Magny. Next up is the headhunting wrestler style. So these fighters have really good grappling. They're hard to take down. And while they do have good grappling, they prefer to use it to keep the fight on the feet and then search for the headshot. So these are fighters like Josh Koscheck, Brendan Schaub, and Rashad Evans. Next up is the high-risk sub-artist. So these are fighters that often put themselves in harm's way, and they usually lean on their submission skills to get the win. It's a very ineffective style. They hold no historical advantage over any of the other styles, and we'll get into those historical advantages in a bit. And they do get submission wins fairly often. Examples include Alexei Olenek, Gerald Meerschaert, and Mickey Gall. Next up is the patient power puncher. So these are fighters that have a low volume but a high knockdown rate. They also get a lot of TKO wins. Examples include Anthony Johnson, Vitor Belfort, and Francis Ngannou. Next up is the pressure wrestler. So these are fighters that focus on their wrestling and they smother their opponents, lots of chain wrestling, and they don't give their opponents the opportunity for offense. So they're going to absorb very few strikes, but they also don't throw very many strikes themselves. But their grappling statistics are far superior to most other styles. Examples include Michael Chiesa, Carla Esparza, and Tito Ortiz. Next up is that stand and bang style that I went through in the examples. So again, they like to keep the fight on the feet and they throw a lot of punches. They also get hit a lot. They're not afraid to trade. Examples include Max Holloway and Calvin Kattar, pictured here on the left, and Angela Hill. Stick and move fighters are next. They're actually very similar to the stand and bang fighter, but a little bit different. They have a lot of volume, a lot of striking volume. They also prefer to keep the fight on the feet. They're not particularly accurate, but they frustrate their opponents with consistent striking pressure and really good takedown defense. So Robert Whitaker, Michael Bisping, and Al Iaquinta are some examples of this style. And then finally, the tactician style. So these fighters make all the smart decisions. They are measured in their striking and their grappling, and they don't put themselves in danger very often. They're super patient and they're effective in just about every area of the fight. Examples include Valentina Shevchenko, George St. Pierre, and Beneil Dariush. So now I want to look at the matchups between the different styles. So what you're seeing here on the rows is all of the different styles, and then across the columns, the styles again. So in each intersection of the rows, you're seeing a matchup between two different styles. And the percentages in the cells are the win percentage of the row column style. And so when you see a deeper blue, that means that the row style wins out more often. When we see a deeper orange, that means that the column style is winning more often. So basically, when you see a lot of blue across the row, that means that style is a very effective style, and orange means it's a less effective style. So if you look at the high-risk sub-artist there in the middle, you can see it's all orange all the way across, meaning that this style does not have a stylistic advantage over any other style in terms of win percentage across all of the data that I pulled. Whereas if you look at the bottom at the tactician style, you can see that they have an advantage over just about every style. Well, not just about, every other style in this list. And then there's some interesting matchups as well. So if you look at stand and bang, you'll see a lot of blue. They do well against a lot of styles, but they don't do well against the chinny grappler, where they win only 14% of the time, the pressure wrestler, where they win only 42% of the time, or the tactician, where they win 39% of the time. So you could tell that the stand and bang style has problems with grapplers, whereas the stick and move style right below, they have a 62% win percentage against the chinny grappler and a 66% win percentage against the pressure wrestler, meaning that they do not have that same problem against grapplers. But at the same time, when you look at stick and move versus stand and bang, you can see that stick and move wins only 41% of the time, while stand and bang wins 59% of the time. So it's this interesting combination where stick and move style does better against grapplers, but the stand and bang style actually does better against the stick and move style. So it's this kind of interesting game of rock, paper, scissors. Next, I want to show what it looks like when you look at one fighter versus another fighter. And so here we're looking at Colby Covington versus Jorge Masvidal. This is a matchup coming up in the UFC in the next couple of weeks. On the left side, we see Colby Covington's breakdown by style. And on the right side, Jorge Masvidal. These are calculated using those similarity scores between the fighters' statistics and each centroid for the different clusters. And so on the left, you can see that Colby Covington is a headhunting wrestler, a bit of a tactician as well, stick and move. These are his three top styles. On the right, you see Jorge Masvidal as a grinded out fighter, patient power puncher, and a bit of a tactician as well. And so then in the middle, what you're seeing is what happens when we compare the top styles for Colby Covington in the rows versus the top styles for Jorge Masvidal in the columns. And so the upper left corner is going to be the most important for this matchup because this is showing their top styles as they match up and what is the historical win percentages for each. You can see it trends blue in the upper left corner, meaning that Colby Covington stylistically has the advantage in this particular fight. So next up is data presentation. I created a set of Tableau public dashboards. The first is fighter matchups. So this shows fighter statistics that might be interesting in the fight, things that'll tell you, is it likely to be finished in a particular way? Is it likely to be a submission or a TKO victory? How do these two fighters win and lose historically? It also shows some of their key characteristics, defensive and offensive characteristics, how they match up, who has the advantage, and of course that stylistic matchup that I just showed in the last slide. I also have a fighter profile dashboard, which shows how a fighter's metrics and also their fighting style has changed across time. Then I've got fight style comparisons. So this is looking at those different fighting styles. How do they match up? How do they compare in key fight metrics? So those box and whisker plots that I showed earlier, where you can look at one fighter style versus all others. You could also use parameters to pick two fighter styles and compare them against each other, look at their box plot distributions for different fight metrics. And then finally, I've got stat exploration dashboards as well. So I've got scatter plot, box and whisker plot, and histogram plots where you can pick different metrics and then look at color coding by weight class or by these dominant fighter styles, for instance. These are all things that you can see on my Streamlit web application. The code for that application's available on GitHub, and I'll be sure to put the link to that Streamlit application in the description of this video. So next steps for this particular project. First, I'd like to include betting odds. So there's a lot of times where the fight data can't really tell you the full story. You know, there's new fighters that don't even have a lot of data available yet, or there might be, fighters have different opponents across time. A lot of time fighters get stronger opponents as their career goes on. It's kind of a career arc. Maybe it starts to dip after the peak of their career, but the opponent is very important and it changes fight statistics. So it doesn't tell the full story to look at a fighter's fighting style or their statistics over their past however many fights. You need to take into account a lot of things. And the odds makers do take into account these things. So their opinions and the betting odds are an important data point that you really can't get just from the fight data alone. Next, there's also the consideration of creating a fight prediction model. The primary limitation here is that fighters just don't have that long of careers. 15 fights in the UFC might be considered a very long career. And that's not a lot of data. That's not a lot of opponents. Who knows what kind of opponents they face, what this can tell us about their fighting style. And so with all of that in mind, I don't know that this marginal improvement in the betting, if it even came about, would be worth the effort of building this fight prediction model. Thanks for your time. Appreciate you listening. I'm going to provide links to my full project write-up. I'll also do a code review and a review of the Streamlit application in another video, and I'll be sure to provide a link to that Streamlit application as well. Thanks.